Here we have a pre-calculus question on trigonometry. Okay, let's go the question. Find sine theta and tangent theta given cosine 2 theta is equal to 3 over 4 with theta terminating in quadrant 3. Okay, so using this information, using the value of cosine 2 theta, that is 3 over 4, we have to find the value of sine theta and tangent theta. Okay, here in cosine 2 theta, the angle measure theta is multiplied by 2. That is, the angle measure is doubled. So we have to use the double angle formula for cosine theta, that is cosine 2 theta. So already we know that the double angle formula for cosine, that is cosine 2 theta equals to cosine square theta negative sine square theta. Okay, so from this formula of cosine 2 theta, we can find two more variants. That is, cosine 2 theta is equal to, already we know that, so cosine square theta equals to 1 negative sine square theta. So if I plug in 1 negative sine square theta for this cosine square theta, so then the formula on the right side, will become, so 1 negative 2 times sine square theta. So this is another variant of formula for cosine 2 theta. And also we can write one more variant for the formula of cosine theta. So in this one, in cosine square theta negative sine square theta, we know that sine square theta is equal to 1 negative cosine square theta. That is using Pythagorean identity. So if I replace the sine square theta by the equivalence of 1 negative cosine square theta, then this expression will become 2 cosine square theta negative 1. So I have given three formulas for cosine 2 theta. So the first formula we have for cosine 2 theta in terms of cosine theta and sine theta. And the second one we have for, the second formula here we have for cosine theta only in terms of sine. And in the third one, we have the formula for cosine theta only in terms of cosine. Okay, here our aim is to find the value of sine theta. So here, so what do we have to do with this cosine 2 theta? So for this cosine 2 theta, either we can plug in this term or this one or this one. Since our aim is to find a sine theta, so we have to replace this cosine 2 theta by the equivalent stuff that we have only in terms of sine, that is 1 negative 2 sine square theta. So 1 negative 2 sine square theta is equal to cosine 2 theta. So we can plug in this stuff for cosine 2 theta, that's over here. Then I'm getting, so 1 negative 2 times sine square theta equals to 3 over 4. So I replace this cosine 2 theta by its equivalent stuff in terms of sine. Okay, so now we have to solve for sine theta in this one. So for that, I subtract 1 from both sides. When I subtract 1 from both sides, this positive and negative one will cancel out. I'm getting negative 2 times sine square theta equals to 3/4 negative 1. Okay, so now let's simplify this one. Okay, to simplify this one, let me write the stuff on the left side. That is negative 2 times sine square theta equals to, whenever I do subtraction between a fraction and an integer, I have to multiply the integer part by the denominator of the fraction. Once I'm done with this multiplication, I can take this 4 as a common denominator. So let me do it, 3 negative. So when I multiply this integer 1 by 4, 1 times 4 is just 4. Now we can take this 4 as a common denominator. So negative 2 times sine square theta equals to 3 negative 4 is negative 1 over 4. Okay, here, so my aim is to solve for sine theta. So for that, first we have to get rid of this negative 2. For that, I have to multiply both sides by negative 1 over 2 to get rid of this negative 2. Negative 1 over 2 times negative 2 sine square theta equals to negative 1 over 2 times negative 1 over 4. So this 2 will cancel out, and negative times negative will become positive sine square theta. On the right side, this negative times negative will become positive 1 over 2 times 4 is 8. Since our aim is to find the value of sine theta, we have to get rid of this square. For that, I have to take square root on both sides. Whenever I take square root for a number, then the sign in front of the square root will be positive or negative. And also here the square root and square will cancel out. I'm just getting sine theta on the left side. On the right side, I'm getting positive or negative. And here we have square root for 1 and 8. For the fraction 1 over 8, we have the square root. So whenever we have square root for a fraction, the square root can be taken separately for the numerator and separately for the denominator. So then I'm getting sine theta is equal to positive or negative. Already we know that square root of 1 is just 1, and the square root of 8 can be a square root of 2 times 2 times 2. So for every two numbers multiplied inside the square root, we can take one number out. So for these two 2's, 1 2 will come out. So 2 times square root of 2. So for these two 2's, 1 2 we take out from the square root, and inside the square root still we have 1 2 that's written over here. Okay, so now let's consider the point over here, theta terminating in quadrant 3. Okay, let me draw the 4 quadrants. Okay, here we have 0 degree and pi over 2, and here we have pi, and here we have 3 pi over 2, and here we have 2 pi. So from 0 to 2, pi over 2, we have the first quadrant, and from pi over 2 to pi, we have second quadrant, and from pi to 3 pi over 2, we have third quadrant, from 3 pi over 2 to 4 pi, 3 pi over 2 to 2 pi, we have fourth quadrant. Okay, so let's consider the concept of ASTC. That means A means first quadrant, and S means second quadrant, and for T we have third quadrant, and for C we have fourth quadrant. So that means in the first quadrant we have A, in the second quadrant we have S, and in the third quadrant we have T, and in the fourth quadrant we have C. Okay, so in the first quadrant we have A. A means all trigonometric ratios are positive in the first quadrant. Okay, in the second quadrant we have S. S means sine theta and its reciprocal cosecant. These two trigonometric ratios are positive in the second quadrant. So the rest are negative in the second quadrant. And for third quadrant, we have T. T means tangent and its reciprocal cotangent. Only these two trigonometric ratios are positive in the third quadrant. The rest are negative. The fourth quadrant, C. C means cosine and its reciprocal secant. Only these two trigonometric ratios are positive in fourth quadrant. The rest are negative. Anyway, so like when we consider the point over here, theta terminating in quadrant 3. So we have to consider the third quadrant over here. So in the third quadrant, we have the alphabet T. T means tangent and its reciprocal cotangent. Only these two trigonometric ratios are positive in the third quadrant. The rest are negative. So we find the value of sine theta. So sine theta is also negative in the third quadrant. Because in third quadrant, only tangent and cotangent are positive. So we find sine theta over here. Sine theta must be negative. So since the value of sine theta in the third quadrant is negative, in this positive or negative sign, we have to consider the negative sign in this one. So in that case, I'm getting sine theta is equal to negative 1 over 2 times square root of 2. Okay, so here still we have a irrational number in denominator, this square root of 2. So usually whenever we get a irrational number in a denominator, we will rationalize it. For that, I have to multiply both numerator and denominator by square root of 2 to rationalize this irrational number. Then I'm getting sine theta is equal to negative 1 times square root of 2 is negative square root of 2 over 2 times. When I multiply the square root of 2 and square root of 2, it will just become 2. So sine theta equals to negative square root of 2 over 4. So now I got the value of sine theta. So that is equal to negative square root of 2 over 4. Okay, so in the next part of the question, we have to find the value of tangent theta. So what's the idea behind finding the value of tangent theta? Already we got the value of sine theta, that is negative square root of 2 over 4. Okay, so using this information and using this part of the identity, that is cosine 2 theta is equal to 2, cosine square theta negative 1, I'll be able to get the value of cosine theta from the given value. So once I get the value of cosine theta and using the value of sine theta we just got now, so we can find the value of tangent theta using the formula, that is tangent theta is equal to sine theta over cosine theta. Okay, let me do it in the next part. Okay, now let's find the value of cosine theta. So for that, I have to plug in the formula for, I have to plug in the equivalent stuff for cosine 2 theta that we have only in terms of cosine theta. That is here we have cosine 2 theta is equal to 2 cosine square theta negative 1. So this is the stuff which is equivalent to cosine 2 theta. In this stuff we have only cosine theta. So because our aim is to find the value of cosine theta now, so in the given value, so we can replace this cosine theta by 2 cosine square theta negative 1. Okay, let me do it. 2 cosine square theta negative 1 equals to 3 over 4. Okay, now we have to solve for cosine theta. For that, I am adding 1 to both sides. So positive and negative 1 will cancel out. I am getting 2 cosine square theta is equal to 3 over 4 positive 1. So 2 cosine square theta equals to so to add a fraction and an integer, I have to multiply this integer by the denominator of the fraction. So once I'm done with this multiplication, I can take this 4 as a common denominator. So I'm getting 3 positive. 1 times 4 is 4. Now we can take this 4 as a common denominator. Okay, now we have 2 cosine square theta equals to 7 over 4. Okay, now we have to get rid of this 2. For that, I multiply both sides by 1 over 2. So when I multiply both sides by 1 over 2, this 2 will cancel out. I'm getting cosine square theta equals to 7 times 1 is 7 and 4 times 2 is 8. I'm getting 7 over 8. Okay, so to get the value of cosine theta, we have to get rid of the square. For that, we have to take square root on both sides. So when I take square root on both sides, the square root and the square will cancel out. And when I take a square root for the number, so I have to take a positive or negative sign in front of the square root. So I am getting cosine theta is equal to positive or negative square root of 7 over 8 is here. So actually we have the square root for the fraction 7 over 8. So the square root can be taken separately for the numerator and separately for the denominator. So then we have cosine theta is equal to positive or negative, and square root of 7 can be kept as it is, and the square root of 8 can be written as square root of 2 times 2 times 2. So cosine theta is equal to positive or negative square root of 7 over 2 times square root of 2. So inside the square root, for every two, whenever we have two same numbers multiplied inside the square root, for that one we can take one number out. So for these two twos, one number will come out, and 1 2 will come out. So this 2 is still in square root. So the simplification of this one is 2 times square root of 2. Okay, so here we get positive and negative. Already we have discussed the theta is in theta is in third quadrant. In third quadrant, only tangent and its reciprocal to cotangent are positive. The rest are negative. So this cosine theta is also negative. This cosine theta is equal to in this positive or negative sign, we have to consider negative sign because cosine theta is a negative in the third quadrant. So we have negative square root of 7 over 2 times square root of 2. Okay, so now I got the value of cosine theta in the third quadrant, that is negative square root of 7 over 2 times square root of 2. But we have to rationalize the denominator because we have an irrational number square root of 2 in denominator. For that, I multiply both numerator and denominator by square root of 2. Then I'm getting cosine theta is equal to negative. So whenever I multiply two square roots, I can take square root in common. I can multiply the numbers inside the square root. And 2 times square root of 2 times square root of 2 will become just 2. So cosine theta is equal to negative square root of 14 over 4. Okay, so now I got the value of cosine theta. So actually our ultimate aim is to find the value of tangent theta. Already we got the value of sine theta. Now I got the value of cosine theta. So using the value of sine theta and cosine theta, I'm going to find the value of tangent theta according to the question. Okay, let me do it in the next part. Okay, here we have the value of sine theta. We already got it. There is negative square root of 2 over 4. And also we got the value of cosine theta, that is equal to negative square root of 14 over 4. Okay, now let's find the value of tangent theta. So according to the question, we have to find the value of tangent theta. So we know the formula for tangent theta, that is sine theta over cosine theta. And for sine theta, we know the value, that is negative square root of 2 over 4. For cosine theta, we have the value negative square root of 14 over 4. Okay, we divide two fractions over here. So this negative will cancel out. And so whenever we divide two fractions, we have to take the fraction in numerator as it is, that is square root of 2 over 4. And we have to change this division as multiplication. And also we have to take reciprocal for the fraction in denominator. Then I'll be getting 4 over square root of 14. So this 4 will cancel out. So then tangent theta is equal to square root of 2 over square root of 14. Okay, still it can be simplified, that is square root of 2, and this 14 can be written as, actually square root of 14 can be written as square root of 2 times 7. So 2 times 7 is 14. So whenever two numbers are multiplied inside the square root, we can take square root separately for each number, that is square root of 2 times square root of 7. So the square root of 14 can be written as square root of 2 times square root of 7, so that we can cancel, for square root of 2 will cancel out. So I am getting tangent theta is equal to 1 over square root of 7. But here the denominator is an irrational number. To rationalize this denominator, I have to multiply both numerator and denominator by square root of 7. So tangent theta is equal to 1 times square root of 7 is just square root of 7. Square root of 7 times square root of 7 is just 7. I got the value of tangent theta, that is square root of 7 over 7. So we have to find the values of sine theta and tangent theta. Already we got the value of sine theta, that is negative square root of 2 over 4, and the value of tangent theta equals to square root of 7 over 7.